Hello and welcome to this Scientific Principles video with Electraining. In this video we take a look at resistors, and in particular when resistors are connected into a circuit in series. First of all then, let's answer the question, what is a resistor? Here we have a picture of a number of resistors, and these are small electronic components, so they are used in electronics a great deal. And you'll find resistors in your mobile phone, in your computer, in your television and so on. But it's not just in electronics that we find resistors. This is an electric kettle. Well, the electric kettle has an element, and the element of the kettle is actually a large resistor. And it helps us to see the principle at work here with resistors, because they enable us to harness the electrical energy to do work for us. So when current passes through the resistor, in this case through the element of the kettle, it gets hot. And of course that heat heats up the water and we can have a nice cup of tea. So we're using the electrical principle there of resistance to do work for us. We're making the electricity do work for us. Now, there are different ways that resistors can be connected into a circuit. We call these series, parallel, and a combination of the two, which we call series parallel. Now this determines the name that we use to describe the circuit. So in other words, how the resistors are connected into the circuit determines the type of circuit that it is, what name we would give to the circuit. We're going to take a look at how resistors will be shown in a diagram now. So in a series circuit, that means a circuit in which the resistors are connected in series, you may see something like this. Here we've got three resistors. The rectangle is the symbol for a resistor, so three rectangles, and they're identified as R1, R2 and R3. You'll notice that there's a dot at the beginning of the line and a dot at the end of the line, and that's because it represents a complete circuit where those dots would be the terminals of perhaps a battery or some other source of electromotive force. So although it's a straight line, it represents a complete circuit. The second diagram is perhaps an easier to understand one in that it shows, the drawing itself shows that it's a complete circuit. It's more obvious. And we have here the symbol for the battery. Remember, it's a long line and a short line parallel to each other. The long line is the positive terminal of the battery. The short line is the negative terminal of the battery. And in this case, we've just got two resistors marked R1 and R2. Now we're going to work through an example where we are going to calculate the total resistance of the circuit shown. So here is a series circuit, this time with four resistors. Notice that they are identified R1, R2, R3 and R4. So however many resistors you've got in the circuit, you just identify them all with a number so that we know which one we're talking about. And I've allocated a value of resistance to each one. So you'll see 2 ohms, 5 ohms, 8 ohms and 3 ohms. Now the good news is that when you're calculating the total resistance of a circuit where the resistors are connected in series, it's as simple as adding them all up. Yep, so if we put the numbers in, it would be 2 plus 5 plus 8 plus 3, which gives us a total value of 18 ohms. Now I have written there in the middle the formula. You wouldn't necessarily need to write the formula down to do the calculation, because once you know that you just add them up, it's as easy as that. But the formula would be RT, because that stands for the total resistance, is equal to R1 plus R2 plus R3 plus R4. And if you had more resistors, you just keep adding them on until you've added them all together, and that gives you the total. It really is that easy. And it brings us on to the first rule that we need to remember about series circuits. In a series circuit, the resistance adds up. I just want to remind you what I mean by a series circuit. It's simply a circuit where the resistors are connected in series. So in a series circuit, the resistance adds up. There are some other rules to series circuits, and we'll look at those in future videos. But for now, thank you for watching.